This meeting is being recorded.
For problem 9 from chapter 12, we are given the names of 3 compounds, and we're asked to identify the reagents that can be used to achieve these transformations. So we have to not only look at our starting material, but then our goal is to form in part A primary alcohol, in part B a secondary alcohol, and then part C a tertiary alcohol. So I've drawn out our starting materials and then what our products could look like after these transformations. So in part A, we're told that we have a 1-hexene. So that's what we see here. We have 1, 2, 3, 4, 5, 6 carbons in our longest chain, and between carbons 1 and 2, we have our double bond. So we're asked to form a primary alcohol in this scenario. So we know that we would need to have reagents that would generate an anti-Markovnikov addition, because Markovnikov addition will give us a secondary alcohol at that site there. But we want our hydroxyl group over here. So we need anti-Markovnikov addition. So reagents that could facilitate this would be if we used borane, BH3, and tetrahydrofuran, and then in step 2, we could use hydrogen peroxide in basic condition. So we would use the reagents for a hydroboration oxidation, and we could accomplish our primary alcohol. In part B, we are given 3,3-dimethyl 1-hexene. So the 1-hexene part is the same, 1, 2. On our carbon 3, we see that we have 2 methyl substituents, and I just realized I did not draw those in our product. They're still there. They haven't disappeared, but what has changed is that our double bond, we've performed an addition reaction again to facilitate or transform this alkene to an alcohol. And we can perform this using a Markovnikov addition. So this one is okay, right, to do our Markovnikov addition because our more highly substituted carbon has the OH installed, and then our hydrogen will be over here at the least highly substituted spot. But we may be concerned with carbocation rearrangements because this site here will give us a tertiary alcohol, and we want this secondary alcohol product. So to ensure that we do not have carbocation rearrangements, we could use oxymercuration, demercuration. So we could use our mercuric acetate here in water in step 1, and then in step 2, we could use our sodium borohydride reducing agent. So this would accomplish our secondary alcohol through Markovnikov addition without the risk of carbocation rearrangement. And that brings us to our last structure. So we have 2-methyl. So we see at our carbon 2. On our hexene, we have our 2-methyl 1-hexene. And in this scenario, we want to generate a tertiary alcohol. So the only site that would generate that would be if we installed our OH group, where I put that dot above our carbon 2. So from this starting material, we could again have a Markovnikov addition. So this would be okay to do Markovnikov and install at the more highly substituted position. And we do not have to worry about carbocation rearrangements. So we could do something like an acid catalyzed hydration, and we could use dilute sulfuric to accomplish this transformation in part C.